The multiplier effect. Why is Cookie Monster on the title slide? See if y'all can figure that out. We have the aggregate expenditure model, also known as the consumption function graph, where consumption equals disposable income. Here's a spring break example. Let's go to Padre Island and party with the multiplier. During spring break, college students like to head to South Padre Island like a designated driver. The multiplier goes along too. With dollars in their pockets, the students spend money on food, drink, motel rooms, and dance clubs, etc. These dollars raise total income of the island by some multiple of itself. College students buy pizza, beer, soda. The people who sell all the pizza, soda, and beer rooms find their incomes increasing. They spend some of the increase and they save some. MPC over MPS. The part spent or consumed generates additional income for others who will spend some and save some. If students spend $8 million on South Padre Island and the MPC is 0.6, then the economy of the island will increase by 20 million. Let's figure that out. Multiplier is 1 over 1 minus MPC. What does it all mean? The economy is composed of continuous flows of expenditures and income. When you spend it, it becomes new income for someone else. So the multiplier effect means that a small increase in investment can cause GDP to change by a larger amount. Okay, I got interrupted. Anyway, what does it all mean? The multiplier effect means that a small increase in investment can cause GDP to change by a larger amount. See the graph. Things to remember about the multiplier. The multiplier will affect everything in Sig X. The multiplier works in both directions. A change in spending will result in an upward or downward shift of the aggregate expenditure curve. The multiplier effect is determined by how much of new money in the economy is consumed, MPC. So the greater MPC is, the larger the multiplier, or the smaller the MPS, the larger the multiplier. Inverse relationship between MPS and multiplier. The multiplier effect, not to be confused with the butterfly effect. The multiplier effect, a change in AE, leads to a larger change in equilibrium real GDP. Equilibrium GDP will increase by a multiple of the multiplier. And we have an example where the multiplier is 4. They're small numbers. A change in Y, real GDP, would be 80. Initial change in expenditures, 20. So 80 divided by 20 is 4. Change in GDP is 80. Multiplier is 4 times the change in expenditures, 20. Here's another table that shows you some of the calculations of ways to get the multiplier, 1 over MPS or 1 over 1 minus MPC. Sometimes you're given different numbers to plug in. You probably want to write these formulas down, although pretty much gonna memorize them after you practice a little bit. 0.1, 0.9, 0.2, 0.8. If government raises taxes, the result will be a decrease in GDP, but not by the same multiple as the multiplier effect. Taxes reduce disposable income, so equilibrium, the real GDP equilibrium will be reduced by MPC over MPS. This is called the tax multiplier effect. Taxes affect aggregate expenditures through consumption, spending, and savings. Government purchases affect aggregate expenditures only through consumption. Let's say real GDP is 550 billion, taxes increase by 20 billion, MPC is 0.75. What will be the effect on GDP? We've got our Sig X here. 550. The tax multiplier effect. NPC over NPS. Change in GDP equals the tax multiplier effect times change in spending. The balanced budget multiplier. Oops. The balanced budget multiplier and equal change in government spending and taxes will change aggregate expenditures or total spending by the same amount. President Clinton used this strategy to help the economy grow in the 90s. And this lovely aggregate supply, aggregate demand graph is what we are building up to. Previews of coming attractions.